Hey, this is Mrs. Slauson, one of the Algebra 2 teachers. I am taking care of the review from questions 29 and on. So we're going to start with graphing polynomials. The first thing I'm going to have us take a look at is the y-intercept. And all y-intercepts have an x value of 0. So I'm actually just going to go to the original problem and put 0 in for all of the x's. So just rewriting it right above, it's going to be y equals, that x is not negative, it's actually -1. And then it's going to be 0 to the fourth power, and then in parentheses 0 plus 2, and then in parentheses 0 minus 3. So if I just keep walking through that, just moving up, 0 to the fourth power is 0, 0 plus 2 is 2, and 0 minus 3 is -3, and I realize I wrote the second power to the third power. -3 to the third power is -27, and when I go through and just multiply all of this, I'm going to get y as being 0. So there's my y-intercept, 0, 0. Now let's talk about the shape. So the shape is based on the leading term when it's in standard form. So I don't want to take a lot of time and write this out, but what I want to pay attention to is that there is a -1 in front, and that there are 4 x's from x to the fourth. There's another x from x plus 2, and 3 more x's from these 3 x minus 3's. So if I go through, the first thing that I'm going to notice is that this negative is going to make my shape flip. And then when I go through and just count how many x's I have, 1, 2, 3, 4, 5, 6, 7, 8, this x to the 8th is having a -1 in front of it, and that's going to give me a shape that kind of looks like this in the end. So even without graphing it, I can go to my end behaviors and write this. I know that when x is getting smaller, so that's this left side of the graph, x is -infinity, that my f of x is also getting smaller. It's going down. Okay? And then when I do the right side, when x is getting bigger, so that's the right side of the graph, f of x or y is also getting smaller, just like it did on the left side. So I don't even need to graph it to get this part. So this part's real quick. The x-intercepts. So the x-intercepts are going to come from the factors and how many times they appear or how many times their solutions appear, because that will determine the bounce wiggle cross. So starting with this first set, looking over here, these 4 factors all have the same solution. They are x equals 0. And since they show up an even amount of times, that's going to be a bounce. And then looking at the next set, this x plus 2, that just shows up once. So the solution there is -2, and since it shows up once, that's going to be a cross. And then the last set, this x minus 3, since it shows up 3 times, I'll have a wiggle, and the solution is x equals 3 with a wiggle. So I'm going to come over here and mark my points. So my x is 0 also happens to be the y-intercept that I marked, but I'll put a b here for a bounce. I'm going to have -2, 0 where it crosses, and I'm going to have 3, 0 where it will wiggle. So what I do now is I first start drawing the end behaviors. So I come over to my far left point and I make it go left just like it went left here. And then I go to the far right and I'll make it go down as well, because on the right it went down. And now I'm just going to go left to right, connect the dots, and pay attention to cross, bounce, and wiggle. So just continuing, it's going to cross here. Whoops, I didn't make a cross. Hold on. All right, it's going to cross through. When it gets to 0, it's going to bounce off. It's going to come back up, have it turn somewhere, and then when it comes back down, it's going to wiggle its way through 3. And that's not a great shape, but it's pretty good. All right, going into number 30. So on number 30, I'm going to be using a lot of the space down here. So again, let's start with the shape and the y-intercept. So my leading term is going to tell me that this is a shape that kind of looks like this. Okay, it's a line that's going uphill. And my y-intercept is when x is 0. So if I just go through the problem and I put 0 in for all of these x's, so 0 cubed minus 7 times 0 squared plus 14 times 0 minus 6, what ends up happening is all of these terms become 0 minus 0 plus 0 minus 6, and I'm left with -6. So my y-intercept is going to be down here at 0, -6. So now what I need to do is find my factors, my x-intercepts. So what I would normally try to do is go to the original problem. I'm going to do a little erasing here. And with 4 terms, I would try to group them. And as I group them, in my first set of parentheses, I take out an x squared, and then I'm left with x minus 7. And then I would want a matching set on the other side of x minus 7. And there's no way I can take this 14x minus 6 to get this x minus 7. So this isn't factorable. So what you do now is you make your list of numbers based on the rational root theorem. And it says I should take the factors of negative 6 and put them over the factors of 1 as a fraction. So my factors of negative 6 are going to be positive, negative 1, 2, 3, and 6. My factors of 1 are going to be positive, negative 1. And then I'm going to make fractions, and this will be my numerator, and this will be my denominator. So all of these numbers are just going over 1. So the final list of numbers that we should test is 1, 2, 3, 6, and negative 1, negative 2, negative 3, negative 6. So you start going through and use your synthetic division, and you find a number that works. And you're going to know that it works because you'll get 0 at the end. So I've gone ahead and tested the numbers, and the first number that actually works is 3. So usually 1, negative 1, 2, negative 2 works, but in this case 3 ended up working. So now I'm going to take the numbers that I see up here in the original problem, so 1, negative 7, 14, and negative 6, and put them in this box. So again, I've already tested this, so I already knew which one worked. So I'm going to bring the 1 down, and 1 times 3 is 3. Just add the next column up, multiply 3 and negative 4 and get negative 12, add this column up, and 3 and 2 is 6, and sure enough it works. So what's going to help me now is I already know one x-intercept. It's this 3. And the factor that would have gotten me there is x minus 3. So now I'm going to get the other factors. So that's where I'm going to go to what's at the bottom here. Okay, and working my way from the right to the left, this is my remainder, this is my constant, this is x, and this is x squared. So what I'm going to do is take this and go a little bit further with it. So the first thing I'm going to do, since it's 3 terms, is just try to factor it. So are there factors of 2 that get me to negative 4? And as it turns out, it's not factorable. But I do have a backup method when it's not factorable. But since it's not factorable any further, I'll go ahead and just add this as my other factor because I can't factor this any further. But I still need to see what the x-intercepts are that comes from this. And I should have 2 answers. So that's what I'm going to do next. So when you can't factor, then we have the quadratic formula, which I won't sing. But it goes x equals opposite b, so that's 4, plus or minus square root. So b squared, so negative 4 squared is 16, minus 4 times a, which is 1, times c, which is 2. And then it's all over 2a, so 2 times 1 is 2. So what I do next is just go into the check mark, simplify that down, and I end up getting the square root of 8. And now I got to see what these are worth as decimals because this doesn't help me as a square root. I want to see where it's crossing the x-intercept. So I'm going to go to my calculator and type this in. So I've got my calculator and I'm going to do 4 plus the square root of 8. I'm going to hit enter first and then I'm going to divide that by 2. And I get one x-intercept, although it's not nice, as about 3.4. I just rounded to the nearest tenths. And now I'm going to do this again, except I'm going to do 4 minus the square root of 8. Hit enter, and then divide by 2. So my other answer is about 0.6. So I am going to round these to the nearest tenths. Okay, so now I can go to my graph, and I'm going to put all the x-intercepts on. So over here, I have about 0.6, 0. I have 3, 0, and then I have about 3.40. So these are all the x-intercepts. They all just happen to be on the same side. All right, so I'm going to make these a different color here. So now I'm going to draw my end behavior. So I'm going to go to the left side of the graph and start with that it should be going down like it is right here. So here's the left side of the graph, the y-intercept. And then on the right side of the graph, it's going up. So I'm going to go to the far right graph, and that's this point, 3.4, and I'm going to make it go up. Now all the answers showed up once, so they're all going to cross through. So I'm just going to go left to right and keep going up, cross, turn, and there's your graph. Where you turn again is up to you. That's not something that we're focusing on in Algebra 2. All right, let's move on to the next question. So here we are writing equations. So let's start with, well, they're all 31, but this one. So in 31, what we're going to ask that it's written in factored form, which the directions don't give, but factored form looks something like this. So just putting in some random letters. The main thing is that I have x and y and a. And what I'm going to do is take my x-intercepts, which happen to be -3, 0, which it crosses through, 2, 0, where it bounces, and 5, 0, where it crosses through. And then I'm also going to take one other point, the y-intercept, and I'm going to put all of this stuff into this red mess that you see below. So starting with y equals, here's my additional point. This will be going in for x and y. And then I will be making the factors that would have gotten me these x-intercepts. So under y, I'm going to put -2. Our goal is to find out what a is, so I'll leave that as a. And then in my parentheses, I'll put the x value that we have, which is 0. And actually,